In the earlier video, I asked you to integrate something similar to this. But the thing is, when given this here, you cannot break this up into two fractions. This fraction here is not the same as this. You see, down here, you can break this up into two different fractions here. Whereas this one here, you cannot. So you have to be able to train yourself to spot that this is in the form of this. You see, you have to be able to train yourself to spot something in this form here, because once you can see that it is in this form here, then your initial guess should be the inverse tan, because when you differentiate the inverse tan of x, it would give you something like this, and then you can make your adjustment. Okay, so you train yourself to be able to spot something of this form here. Okay, in fact, train yourself to be able to spot something of this form here, where you have k squared here instead. Because when you differentiate the inverse tan of kx here, then it will give you something along this line, and then you can make your adjustment. Okay, so train yourself to be able to spot something like this, and if you can see something of this form here, then make your initial guess to be this. Okay, and then also train yourself to spot something of this form here, because when you see something of this form here, earlier there's no square root, now we've got a square root. Okay, so earlier up here, you should train yourself to spot something of this form here. If it's of this form here, without the square root, then make your initial guess to be tan, the inverse tan. If you have a square root here, then here train yourself to spot something of this form, in which case make your initial guess to be the inverse sign of kx. Okay, because when you differentiate the inverse sign of kx, then it will give you this. Hang on. So if we try to differentiate this here, let's go back one step. Train yourself to be able to spot something like this. If you can see something like this, then make your initial guess to be this here. Okay, because when you differentiate this, it will give you this. Okay, so now we're going to differentiate to differentiate this. So hang on, one more time. Train yourself to be able to spot something of this form here. If it's of this form here, then make your guess to be this. So now we are going to differentiate this just to see that it will get to this form here. Okay, so we've done this before, so if you don't understand this, then watch some of the earlier videos. To differentiate this here, we would sign equally to both sides. That will then give us this here, and then use implicit differentiation. Remember that y is a function of x, so when you differentiate y, you've got to stick with dy by dx. Again, if you don't understand this, track down one of the earlier videos. So when you're here, use implicit differentiation. Differentiate this will give you cos of y, but because y is a function of x, you need to stick this in, and then differentiate this with respect to x here. That will then give you k. Okay, and then once you're here, here you've got one thing times another thing. So divide both sides by cos of x, then that will then give you this. So dy by dx is given by this, but we don't want in this form. This is still quite messy. So what we do, we would translate this. Okay, so looking back at this here, currently this. Looking back at this here, sine of y equals k of x. Okay, sine of y equals k of x. We need to translate this sine of y into cos of y. So we would look at this. Okay, so looking at that. So currently we are looking at this. So currently sine of y equals k of x. Then to translate this to cos of x, we would create a triangle here where the angle is y here. Okay, then create something that would be true. So let's say this length here is kx, and this here is 1. Okay, the hypotenuse here is 1. If the hypotenuse is 1 and this is kx, then this length must be must be the square root of 1. So it's just us using Pythagoras here. Okay, square this. So if this is kx and this is 1, then this length here must be given by this. Okay. Well, so hang on. So sine of y is kx divided by 1, which is true in this case here. Now using this triangle here, let's translate it to cos of y. Well, cos of y will be this length here, which is this, divided by the hypotenuse, because it's this here is cos. Okay, cos. So this thing divided by 1. Okay, so looking at this here, so call this kx, call this 1. This must be root 1 blah 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 k x squared, which is the same as this, by the way. And so cos of y must be this divided by this, which will give you this. Okay, so basically we were here earlier. We want to translate it to cos of y, because our dy by dx here is given in terms of y. We've done all this before, so if you don't understand it, then track back one of the early videos. So cos of y equals that, and then blah blah blah. So now we've got cos of y equals this. So we would stick this back into here, into here. Okay, put the cos of y into here, because at the moment we've got dy by dx equals this thing here. Now we've just worked out cos of y. So the answer here will be k over y. Will be k over y. So that is so whenever you see something of this form here. Hang on, let's go back. Let's go back to here. So whenever you see something of this form here, then your initial guess should be this, and then make so your initial guess should be this, and then make the adjustment. Okay,